this is yet another tutorial on the chapter Analytical Chemistry, and it's the fourth in under this chapter. And in this video we're going to be covering the topic detection of cations, and hopefully a bit more than that as well. So cations, as you would have studied in the first few chapters, they're basically positive ions. So metals, in order to become stable, lose electrons and acquire a positive charge, and then they are called cations. So over here you're gonna basically learn how to experimentally find out and detect certain cations. How do you know if a compound has, say, the calcium cation or the zinc cation? So that's what we're gonna cover in this video. uh, the best way to learn this is making a simple table, so I'm just gonna do that very quickly. Again, I'm going to try and use the appropriate colors so that um, it sticks to your mind and you can remember it. One more column here, one here. Okay, so over here in this column I'm going to write the cations. I'm just going to write cat. In the next column we're going to write NaOH. uh, and in bracket I'm going to write little, just L over here. In this one I'm not going to write NaOH again, but I'm going to write excess. You'll see why in a minute. And over here I'm going to write NH4OH. First in little amount and then again excess. So this is the format of the table that you should be following. You'll be wondering why I'm using NaOH and NH4OH and what is excess. So basically we're going to be taking certain compounds which contain the cations that we need to detect. So the way we detect them is put NaOH solution into it and just observe the changes that take place. So at first it's put in a few drops, little amount, that's why we call it little over here. Then after that, once the changes are observed, noted down, we put it in excess, in a large quantity. And then the same is done for NH4OH. So by observing the changes we can see which cation is really there in that compound. So I'm going to start off with calcium first. Calcium's cation is Ca2+. It has a positive charge of 2, so valency is 2 as well, that's why. Okay, so when you put NaOH few drops, what happens is that a white precipitate appears. Now some of the terms over here, some of the descriptions are overlapping. So for white precipitate I'm going to use this symbol, like just scribbling a bit of white. So this represents white precipitate. When you put in excess, when you put any compound in excess of NaOH or NH4OH, what you're going to really see is not whether it's going to what color is it going to give you, but you're actually going to see, does the compound dissolve, does it leave behind a precipitate? If yes, does the precipitate dissolve? Is it soluble or is it insoluble? So over here I'm going to write insoluble, I'm going to write it with an I, and soluble with an S. So over here calcium is insoluble. Now in NH4OH, any calcium compound where calcium is a cation, it will give no precipitate. So I'm going to make a dash here, and of course if there's nothing here, there'll be nothing here also. So the way to remember this, at least the way I remembered it, you could write this as a W representing white precipitate. This is I, and over here you can write N and N signifying no precipitate. So remember calcium and remember Win with the double N, that is. So That's the way I remembered it. If it works for you, then you can go ahead. Otherwise, uh, it's not very tough. You can make your own little abbreviation like that. Moving on to the next one, it is PB 2 plus again. Now NaOH little white precipitate again. This is the reason why I am putting this little white scribble again. When you put sodium hydroxide in excess, unlike calcium, it is soluble. So I'm gonna write the S here. Uh, Now if you put ammonium hydroxide, it yet again gives a white precipitate. Now the difference between NH4OH and NaOH in Pb2 plus comes here. In NaOH excess, it is soluble. In NH4OH excess, it's insoluble. Now again, to remember this, I had just put W's over here. It spells Vasui. Now it doesn't really mean anything, but you can just relate that word to Pb2 plus, and that way you could remember it. But obviously you should feel free to make slightly more meaningful words out of this. um, Moving on to Zn2 plus. For NaOH little, again white precipitate. uh, Now for excess, it is soluble, so it's exactly the same as Pb2 plus. Now when you put ammonium hydroxide, it's not white, but there's an important adjective there. I'm not too sure how to represent it here, but it the adjective is gelatinous white. Now I'm gonna make it a slightly grayish shade. Just remember gelatinous. Okay, so I'm just gonna make it a little more darker so you can make out the difference a bit better. Gelatinous white doesn't look anything like this, but I think if you go to the lab and do the experiments, you will see what it looks like. For now, just learn it like gelatinous white. Um, Now in excess, it is soluble again. Now for this again, there's no real abbreviation. You can remember WS, GS, or something like that. Um, and all this you really just need to cram up. There's nothing else you can do about this. So just make your own abbreviations, or I don't know, whichever way you feel comfortable, do it. And remember that this often comes for a whole 5 marks, and that too, all you need to do is just write uh, whether it's insoluble or soluble. That carries one whole mark. So you should know this pretty well. Now the next cation is Fe2 plus, and finally we have some color. Fe2 plus in NaOH will give you dirty green. Now dirty green would probably mean something like this. Dirty green precipitate. In excess, it's insoluble. Now when you add NH4OH to it, it again gives this dirty green precipitate, and it is again insoluble in excess. So this one is easy to remember. It's the only one that is dirty green. It's a unique color, and so you can remember this. It's dirty green insoluble, dirty green insoluble. So that should be fine. Then the next cation is Fe3 plus. Remember that Fe has two valencies, 2 and 3. So now we're going to do Fe3 plus. Okay. So Fe3 plus in a few drops of NaOH will give you reddish brown precipitate. So it's something like this. very similar to the color of NO2, which we did in the previous section. Okay, reddish brown, and it goes the same way as Fe 3 plus. That is, it'll be the same color in NH4OH, and again it'll be insoluble. So I'm just going to make the lines first. And this is for our last cation. I don't have space, sorry about that. Okay, now okay, this is insoluble. Over here again you get the reddish brown precipitate, and again insoluble. So same pattern as Fe2 plus, except it's reddish brown instead of dirty green. Now our last cation is Cu2 plus. Cu2 plus. Okay, so over here it in NaOH, I'm not writing the column names again, it's the same order as the previous one. Okay, so in little NaOH it gives a blue precipitate. So blue precipitate, yeah. And it is insoluble in excess. With NH4OH it again gives the same precipitate, bluish precipitate, but here in NH4OH excess it is soluble. The way I remembered it was, I think you would have guessed now, bibs. Uh, so all you can do is just associate that with Cu2 plus. Now again I'm telling you, these questions do come just normal fill in the blanks. So for just writing 1 or 2 words and memorizing this one simple table, you can get at least 5 marks just straight away. And also, since it's just fill in the blanks, it's also a real time saver in the exam. Chem is only 1.5 hours. You have 80 marks to attempt, and a question like that you attempt 5 marks in less than 30 seconds. I'm not exaggerating or anything. It's actually just writing 2-3 words. So do this very very well. So that's all there is really for this video. Next video we'll be covering detection of anions, not much in that, and maybe 1 or 2 questions as well. So see you then.